Okay, before reviewing the course, I like to show you this one again. There is a concept high level versus lower level, and another concept, another comparison between high LOD, low LOD. LOD means level of detail, okay? So what is LOD? Simply, we experienced this one 2 weeks ago. Take a look. This is original file of Stanford Dragon, which has 100,000 polygons. Another one, 10,000 polygons. So this one, this original Stanford Dragon has 10 times more polygons, okay? So in terms of level of detail, which one is high LOD? Of course this one, okay? This is higher level of detail, lower level of detail. In the same way, take a look. Let's think about you are designing this kind of tower. At the beginning of the project, you can think about its roughly measured height and roughly designed geometric shape in this way, okay? This is the lowest level of detail, okay? Low LOD. But in your progress, at the end, your final product has very fine-grained details in its surface, geometric shape, material, color, and so on, okay? So it's high LOD. Take a look at this space. High LOD simply means more polygons. Lower LODs, fewer polygons in terms of its geometry, okay? But actually we say high LOD to something well developed or highly advanced or highly developed, okay? At the beginning of the project or beginning of something, we usually say lower level of detail. So take a look, building life cycle, planning, designing, kind of lower LOD, okay? But if you dig into the design development, at the end of the design process, your design model has very, very detailed features for your real building design. That is highest level of detail. Even in construction phase, somebody needs even more fine-grained and really detailed geometric shape and information. That's even higher level of detail, okay? So let's think about the conceptual things regarding LOD as well as levels, high level, lower level. So in general, high level means introduction, outline, general theory. This is high level, okay? In other words, it's coarse detail, but it has a big picture, okay? But no details. How about low level? It has detail, particulars, specific theory. In other words, it's fine-grained. You know the coffee machine, okay? Grinders. Grinder, if you use grinder in fine-grained mode, your coffee output going to be really fine-grained coffee, and then you can get some very kind of thick or something coffee. But if you put it in something coarse-grained, which means granularity, each particle is bigger than fine grain. So this is the meaning of coarse grain, fine grain, okay? Let's think about comparison between level of detail. What's the level of detail we pursued in the class? I'm talking about digital design and visualization course, this course. In general, design computing course, okay? In high level, developing the capability of design computing, your capability of design computing, digital design, enhancing your digital communication skills, practicing digital design presentation, something big, okay, something broad. That is high level, okay? How about this one? Training precision drawing tools such as AutoCAD, SketchUp, 3D rendering, visualizations, Photoshop. They are low level, okay? So let's talk about the level of detail. Which one is higher level of detail? Low level, okay? In low level, level of detail is getting higher simply because now we are dealing with some specific tools, specific software, specific details, okay? But in high level, in other words, in lower level of detail, we are dealing with something outline, general things, theory, introduction. We are undertaking in this semester entire part from high level to lower level. Theory course, lecture series, and lab exercises. Even lab exercises has some different levels. Anyway, these are some conceptual things you need to know in terms of high, low level and high, low level of detail. Let's get reviewed some 3D modeling and design visualization issues, exactly what we have walked through, what we have learned. Let me quickly introduce you and show you what we are dealing with, okay, in the course. As I showed you before, there is very famous one single slide history, okay? Review CAD history. The first one is the design is a drawing of the product. For example, geometric drafting in 2D. The second stage, the design is a surface model of the product. Third, solid model. Fourth one, parametric model. The last one is building information model. So where we are, as I introduced you before, we are in the second stage. Okay. You have learned digital design and some design computing related course in our department since when you were freshmen, okay, since last year. So 2 years, we spent 2 years for those two parts. In a metaphor, I can say this is elementary school, this is middle school level, high school, undergraduate, and graduate school level. So in terms of CAD history, we are still in middle school level, okay? 3D Max, SketchUp, Rhino, Maya. Our general 3D geometric tools are all in this category, which means middle school level in terms of its CAD history. So how about next phase things, next semester? That's what I told you before, okay? Solid model, parametric model, BIM models, they are all usually integrated. And the BIM tool, such as ArchiCAD, Revit, they have all those features, okay? All the features it has. So this is the most advanced one. But we are in still this stage. Why we are still in this stage? As I told you before, surface model, lightweight, handy, very, very good to visualize anything. Take a look this one. In the real world, there is no this kind of object. This one has entire surface, zero thickness. But in real world, this one's supposed to be 0.1 millimeter thickness by real product, real material. Anyway, this kind of mathematical definition can be represented by computers virtually. So this is the simple manipulation of surface control, exactly same you control surface in 3D Max, even in Rhino or SketchUp, whatever. But this is not real, okay? Games use surface model 3D, surface-based 3D, simply because this is lightweight, okay? Not heavy loaded, very fast. And this one can visualize anything you can imagine, okay? But how about this one? Solid model. This is real. world object, unambiguous computer representation, which means exactly same mechanism to real world object. So those are non-solid surfaces, dangled single surface, a line. In real world there is no line, okay? No line object. Klein's butter is, this one doesn't have inside outside, okay? 3D version of Möbius string, that's what I told you. So those are invalid, ill-defined 3D. How about devil's fork? This is ill-defined, okay? It's invalid, it's a fake. This one cannot be made in solid model or in real world. How about this one? Ambiguous, okay? This one can be this one or anything else here. So why we need a solid model? Solid model knows if you put a point, it can detect whether this point is outside of this product object or inside of the product, okay? Solid model knows inside and outside, simply because inside is mathematically defined as a solid part, okay? So Boolean operation, cut, inset, extrusion, plus, minus, union, intersection, all the operations are available, no problem, okay? Anyway, this is real-world product representation method implemented in computers, solid model, okay? We need to take a look at the comparison between geometry and topology quickly. Why? We need to know some fundamental basics in computer graphics, okay? So this is geometry and topology in Korean, 위상, okay? Why we need both of them? Take a look at this one. How to define this rectangle shape by computers. Computers understand mathematic, well-defined, precise definition. So take a look at this process. 4 points in XY Cartesian coordinate system, okay? 4 points and their connections. And let computers or this system know this is the surface enclosed, okay? And then computer can visualize that rectangle shape based upon this mathematical definition process. So let's take a look at this one, topology. This is geometry, okay, which has coordinate points. How about topology? Take a look, this connection. Topology defines the relationship between vertices and edges at the end face. Let's take a look at the comparison, topology versus geometry. The first thing is same topology. Let's take a look. I told you topology defines the relationship. Starting point, vertex 0, end point, vertex 0. How about second one? Starting point, end point, same, okay? Vertex 0. But they are looking totally different, which means different geometric shape, okay? They are geometrically different, but topologically same. How about this one? Same geometry in terms of the location of the points, okay? 4 points in the same location, but different relation. In other words, different topology makes totally different output. Take a look, rectangle shape and the cross. So what we need, geometry, topology, both geometry and topology are necessary, okay? Geometry defines values of points, location of points. Topology defines relations between points. Let's take a look some terminologies. On the geometry, point, line, surface, space. on the topology, vertex edge face shell. Those terms are in 3D Max, editable poly. You are very familiar with those terms, okay? So you can control vertex edge face in order to control the final geometry, okay? Problems of unclosed surface. Let's take a look, those three geometric shape. When you extrude using this section profile, number 1, 2, 3. Okay, obviously those two are 3D and they are surface-based 3D, obviously. They are not solid-based 3D, okay? Because this one doesn't have thickness. How about this one? Of course, this is surface-based 3D, but there is a possibility this one can be defined as a solid 3D, okay? In other words, this one can be both solid 3D and surface 3D. But this one only can be a surface 3D. This is not a solid 3D, okay? So we need to define well-defined section profile, enclosed one. So starting vertex, ending vertex supposed to be exactly same, and then we can make this geometry, topology enclosed, and then we can make valid 3D. You remember what we have done when we import CAD file? Take a look this one. Yellow point means starting or ending point, but too many, ill-defined. Why? This one is given geometry. 3D Max doesn't know what is this. So we clean up this line, okay? We clean up that CAD file using weld function, and then take a look this one. This one single shape has one single starting and end point in yellow. So we can make this kind of solid looking 3D geometry without any hollow inside wall, okay? That's exactly what we have used in lab exercise hours, okay? So this is the difference between solid and surface-based 3D definition. Even if this is surface-based 3D modeler, 3D Max, it doesn't matter. 3D Max anyway knows whether it's valid definition in 3D or unclosed section profile for 3D extrusion or something. Okay, let's quickly move on. Geometric modeling versus information modeling. Information modeling is the most advanced direction we are now exploring. Anyway, information modeling for building, simply say we are calling it BIM, because information modeling plus building, that's building information modeling, okay? Information modeling contains anything of geometric modeling. In other words, geometry is one part of information, okay? So let's take a look this one. From 2D drafting to 3D modeling, this is conventional drawings, floor plan, elevation, section, 3D axonometric, and 3D surface model. I told you somebody developed this one, and solid model, but this is just 2D drafting. This is 3D model. Why we need 3D model? Capturing some visualizations from the model. So how to derive elevation, front view? Simply rotate this model in front view and then take the scene or render the scene, okay? What if you need floor plan? Cut the section and then make a top view. That's the floor plan, okay? So rendering, even animation making, all they are some part of this extraction from 3D model. We don't need to draw again, okay? All 2D drawings, draftings are subject to be extracted from 3D model. What's next? I told you, you know what is next. 2D drafting, surface model, solid model. You know what's next. Parametric model and building information model. That's the most advanced one. So why I show you this one? This one is looking iPad, tablet application or your smartphone app named HomeStyler. This one also has PC version. You can access homestyler.com and you can design in both 2D and 3D. The reason why I show you this one is simply this is BIM tool. Okay, this is not AutoCAD 2D drawer or SketchUp 3D Max like 3D surface-based modeler. This is building information modeling tool. Take a look, this PC version. If you click one of the wall object, this HomeStyler, this is not an application. This is web browser. You can use Chrome, Explorer, Safari, whatever, and then you can open this application. This one is working inside of this web browser. So if you click this wall, HomeStyler knows this is wall object. And then you can change wall style, wall opening, and finish the wall color, decoration, and so on. Take a look. This is 3D view of HomeStyler design. This is 2D view, edit mode, and this is 2D edit mode. But if you change the 3D view, you can visualize in this way. You can extract from this HomeStyler to Revit, okay? Not just the simple geometry. Also, you can the CAD file you can extract from this HomeStyler, simply because this is BIM tool, the most advanced one. Even if it's looking web-based, small size application, it has really powerful features, okay? How about HomeStyler mobile version? Mobile version of HomeStyler also has building information modeling approach. It has auto detection of ceiling line, wall line, floor line. And this one can also support the editing function. Take a look. This is just a regular picture of the corridor, elevator hall. And by using this tool, you can change the color of this wall. Even you can load this furniture, even picture frame, and so on, okay? Change the floor material from this stone to the wood floor, okay? By using your smartphone. You can install HomeStyler smartphone version on Android, iPhone, whatever. You can also load any given empty space in order to decorate something like this, okay? If you click one of the material, HomeStyler knows whether this furniture is real world furniture or just geometry. It has price information and it has some material details and lots of associated information you need. HomeStyler, if you click this door object, take a look. Double entry door, cherry color. Simply HomeStyler knows something about this door. You can extract geometry into DWG CAD file. But if you load that CAD file, the same model, okay, this simple design can be extracted to AutoCAD. And then you can click this object, door object. But the problem of AutoCAD is it doesn't know this is door. This AutoCAD only displays layer information, geometric position X, position Y, position Z, Cartesian coordinate system. That's it, only geometry. But if you load this one into Revit, take a look. If you click the same object, Revit knows this is double panel door object and associated properties, door properties, okay? So this is the main difference between BIM and geometry. In AutoCAD, everything in geometric data. In BIM tool, object-oriented definition and associated information. A lot more information you can append. So why this difference has been made? At the beginning of the CAD system, let's take a look at this picture. This is very famous picture, MIT Media Labs Sketchpad, the first CAD system in 1960s. At that time, we are focusing on geometric shapes. So we made something, let computers do what we have drawn. At the beginning of the CAD, without computers, what designers are doing? Drawing, okay? Because we are believing drawing is design. So we just use computers for drawing. That's the earlier version of computer-aided design system. But we are smart. We invent new software, new approaches. At the end, we invented something, let computers do what we have done, okay, including entire process. We are focusing on information, not just geometric shapes, okay? That's the concept of building information modeling, and this is the most advanced features we have invented. So let's compare two same geometry. Take a look. Very simple rectangle shape room, okay? But in SketchUp, 3D Max, AutoCAD, there are 2 points and 2 rectangle shapes. That's it. But in BIM tool, 4 points, 4 walls, and 1 single space, okay? So its formal definition in this diagram also has very different representation. They are looking very same, okay? They are looking very close, but computationally very different. Totally different, okay? That's the point. That's the difference between those two approaches, geometric and information modeling. So what we need to know, what we have learned, you know editable poly, okay? Controlling vertex edge face shell. For the box, we need to control vertex edge face, so-called editable poly mode, topology or geometric control. And we have learned this process and this process, okay? Geometric controlling modifiers in 3D Max, especially in 3D Max. Take a look. You know how to control light object, materials, camera viewing, and this kind of modifiers, editable poly edits, geometry centered, some parameters. What kind of parameters? Width of the box, height of the box, that's the parameters, okay? For editing, update vertex, edge, polygon, lots of geometric things you need to know and you need to control. How about this process, this one? Parametric modeling, building information modeling, such as Revit. For defining this one, you need to define the part component. This one can be used in your design, something like this. Next semester in the Revit family editing and some curtain system making, window making, family making lab exercise, you're gonna learn how to do this. Anyway, looking similar but totally different, okay? There is no overlapped geometry. They are all solid model. They are real-world object-like definitions. Object-oriented modeling and design. Update information is the way of modification, editing.